8.2, one sample interval for the proportion. We're going to be able to construct and interpret a confidence interval for the population proportion. So if we look at our overview sheet, we are on proportions. That's qualitative. This is the only thing yellowed for chapter 8. So this is what we're going to be learning today, confidence intervals. So that's a range of values. We're going to use number 8 on the calculator sheet. Here are the steps to create a confidence interval for one population proportion. So this should look familiar. We're going to state the random variable and the parameter in words. So p hat is going to be the random variable. This is the proportion of n randomly selected objects in some category of interest. P equals the proportion of all objects in some category of interest. I want you to identify n, the sample size, and x, the number of successes. Then you need to check assumptions. Is it random? And there needs to be 2 categories. So you received the flu shot or you did not receive the flu shot. So 2 categories. C, check the sampling distribution that it's approximately normal by completing these. And then number 8 on the calculator sheet to obtain the confidence interval and point estimate. Point estimate, p hat is x over n. So x, remember, is the number of successes, and we should have identified that up here, and n, the sample size. So you should be able to do that by hand if you wanted to. And then state a conclusion in the context of the problem. So we are however percent confident, this will be given to you, that the proportion of all objects that are in some category of interest is between the lower end of the interval and the upper end of the interval. Okay, so let's get into an example. So a researcher studying the effects of income levels on breastfeeding of infants hypothesizes that countries where the income level is lower have a higher rate of infant breastfeeding than higher income countries. It is known that in Germany, considered a high-income country by the World Bank, 22% of all babies are breastfed. In Tajikistan, considered a low-income country by the World Bank, researchers found that in a random sample of 500 new mothers, that 125 were breastfeeding their infants. Find a 90% confidence interval of the proportion of all mothers in Tajikistan who breastfeed their infants. So this would look very familiar. We did this example with hypothesis testing, so you can go back and refer to that if you want. So let's think about these first couple of steps. So state the random variables. So we're going to do p hat first. So 500 new mothers in Tajikistan who breastfeed. Now, if you wanted to look at this, we did this on the very last example on chapter 7 for hypothesis testing. P is the proportion of all new mothers in Tajikistan who breastfeed. That is your parameter P. Okay, state the assumptions. Is it random? Yes, if it's not stated, we can assume. There's the random B. 2 outcomes. They're breastfed or not, or breastfeed or not. And then C. Okay, before we begin, back into number 1, we need to identify N, the sample size, and X, the number of successes. So breastfeeding is considered the success. There was 500 mothers. That's your total. And how many successes were there? How many breastfeed? 125. So that will help you with C. For C, it's asking N times P hat. So we need to find P hat. P hat is X over N. So it's 125 over 500. And when you divide that, you get 0.25. So we have n times p hat. That's 125. That's greater than or equal to 10. Then we have 500 times 1 minus p hat. And that equals 375. That's greater than or equal to 10. And then capital N, your population is greater than or equal to 20 times your sample size. So N is greater than or equal to 10,000. And yes, we can assume there was more than 10,000 pregnant ladies in Tajikistan. We're going to move on to number 8 on the calculator sheet to obtain the confidence interval and p hat. If we go to the calculator sheet, we are number 8. You're going to go to the data list tab, the 1 proportion confidence interval p-value, and then we're going to edit the x, n, and confidence level percent. So data list tab, 1 proportion confidence interval, CI means confidence interval. X was 125, N was 500, and then don't forget the confidence level 90%. Now if you're not sure about these two, these are our hypothesis testing, but if you were to edit these, keep an eye on these numbers, the confidence interval, the lower and upper. If you were to edit these or delete, these are not going to change the confidence interval. So this is kind of good to know that you can't really screw it up too much. Just remember, anything in black is what you can edit. This is the p hat that we had calculated earlier for our assumptions. So our confidence interval, the lower is 0.218 to the upper of 0.282. Let's write that down. Our confidence interval, 0.218 to 0.282. P hat was the 0.25. Another way you could write this is 0.218, and your P is greater than that and then less than 0.282. So this will always go here and this one will always go here. This will stay the same. This is your upper bound. So lower bound. This is your upper bound. I'll write those out for you. Lower bound, upper bound. And then let's state a conclusion in the context of the problem. We are 90% confident that the proportion of all new mothers in Tajikistan who breastfeed their infants is between 0.218 and 0.282. You could also say between 21.8% and 28.2%, if that makes more sense to you. So sometimes these intervals are reported as what follows. We estimate that 25% of all new mothers in Tajikistan breastfeed their infants, within a margin of error of about 3.2%. So this 25% is the middle, and then you add 3.2% margin of error, and then you subtract 3.2%. So P hat is the 25%. Okay, in ours, you can see 25. And then the margin of error, 3.2%, which gives you, when you add these, you get 28.2%, 21.8%. I will show you in a little bit of how we could calculate the margin of error when you are provided the upper and lower bound. Okay, so find the 99.9% confidence interval for a sample size of 268 with 134 successes. Write your answer as an open interval, so that means with parentheses, using decimals, so not percentages, accurate to 3 decimal places. Okay, we have n is 268. Our successes is 134. Confidence of 99.9. Go ahead, go to our calculator sheet, type that in. 134, 268, and then confidence of 99.9%. So we're between 0.399 and 0.601. So parentheses, the lower goes here, 0.399, and upper 0.601, and they're not percentages. And this is your confidence interval. Okay, so hopefully that helps. In a recent poll, 430 people were asked if they like dogs. So right away, that's your total sample. 24% said they did. Find the margin of error of this poll, 90% confidence level. Okay, we have N is equal to 430, 24% they did. So 0.24 is like your p hat. Remember, p hat equals x over n. So if you ever get this, you have to solve for your x. How many successes did you have? So you take 430 times 0.24. That will get you 103.2 successes. Okay, let's plug that in. 103.2 successes out of 430. Don't worry about decimals here. I know it logically doesn't make sense, but you're going to want to put those in there. And the confidence level of 90%. So we are between 0.206 and 0.274. So I'm going to write that 0.206 and 0.274. We want to find that margin of error. So our p hat is in the middle. So 0.24 is right in the middle. Right? So you can take 0.24 minus your lower. You can get 0.034. Now say you didn't have the p hat, which you should always have the p hat, right? Because it's always going to be calculated for you. So that's one option. Or you can do it right here. The margin of error is denoted by E. You take your lower, or sorry, your upper, minus your lower, and then divide by 2. So when you subtract those, and then divide at the end, you get 0.034. So this is going to be margin of error. This margin of error is very similar to what we did in 8.1, but now we have proper notation for it. And this is p hat. P hat is right in the middle of your data. It's right in the middle. So to get that, you just add the lower and upper together, divide by 2 to get p hat.